Welcome friends. First of all, we shall give the answer of the previous lecture. That the question was, we have to give an example of a binary operation which is neither commutative nor associative. There may be some other examples, but here I give a special example. If we consider a set V is a set of vectors in R3. Then V with क्रॉस प्रोडक्ट ऑपरेशन इस बाइनरी ऑपरेशन, क्योंकि V से अगर दो एलिमेंट पिकअप किया जाए A B if belongs to V, then their cross product which is defined by sin theta into n cap, where if the vectors are like this, if the internal angle between them is theta, then A cross B will be a vector which is both perpendicular to the plane of the vectors A and B, and n cap is denoting the right-handed direction as definition. Okay, then this vector A cross B will also be a member of the set V. Therefore, V cross is a binary operation. Now, we shall show that A cross B is not equals to B cross A. That is, if we have two vectors, then A cross B will be in this direction, but B cross A will be in the opposite direction but of the same magnitude. Therefore, A cross B is not equals to B cross A. Then B cross is not commutative. A cross B cross C is equals to, whereas these are very much pretty results of vector algebra. Then if we call it equation 1 and if we call it equation 2, then from equation 1 and 2, A cross B cross C is not equals to A cross B cross C. Now we shall start our discussion of group theory. Firstly, we shall define what is group. Suppose G is a set and star is a binary operation on that set G. Then the pair G comma star is said to be group if Number 1, star is associative. Number 2, there exists an element E in the set G such that A star E is equals to E star A is equal to A for all the elements in the set G, and this particular element identity element. And number 3, for all A belongs to the set G, there exists an element A inverse. We shall call it inverse element in the set G such that A star A inverse is equals to A inverse star A is equal to the identity element. Now this group G star is said to be commutative or abelian if for all A B belongs to G, A star B is equals to B star A. So with these 3 conditions, we have another extra condition. If this condition also holds, then G star will be called commutative or abelian group. Now we shall take some examples. First example is very trivial one. If the set G is the identity E itself, then this group is called trivial group. Second example is if we take R with the usual addition, then this is also a group, because for every element in the set R, 0 is identity and for all A in R, minus A in R is the inverse, because A plus minus A is equals to minus A plus A is equal to the identity element. Third, multiplication. Is this a group? The answer is no, because 0 is in R, which does not have an inverse in R dot. So now R star dot is a group. Here 1 is the identity and 1 by A is the inverse of A. Similarly, C star dot is also a group. Q star dot is also a group, but Z star dot is not a group, because 2 belongs to Z star, but 2 inverse does not exist in Z star. So these are very pretty and easy examples of group. In the next lecture, we shall give a lot of examples of group, and all the examples will be non-trivial examples before going to the deeper concept of group theory, because we should have lot of examples in our hand to test every theory of group in every instant. So before starting the examples of group theory, we should have at least 40 to 50 examples of groups we should know at least.